Hello and welcome everyone to this, our sixth lesson within the cycle of 18 that make up the developer program for Sage CRM. We are a third of the way through, and today we're going to be looking at the final type of screen-based rules, the validation rules, and then we'll be going on to explore table and entity level scripts. Now, each of the topics in today's session could themselves be an entire day-long course. There's a lot to learn about these, and we've only got about 60 minutes at the most. So what I'll be doing today is giving you an overview of each of these and pointing at the different learning opportunities that you have, typically going off into the documentation and going off into the materials that exist up on the Sage Community Hub. As I said, this is the sixth lesson within the cycle of 18 that make up the full program of what we're going to be looking at. I can't believe that we were already, as I said, a third of the way through, and today we are going to finish off those screen-based rules, looking at validation rules, start to understand the nature of how rules are dependent on screens, the definition of the blocks that we're working on, and interestingly look at how Sage CRM gives us a type of script that takes place much more independently of the individual screen and onto the transaction with the record and the table, but there's a form that is intimately tied to complex screens, and we will see what I mean by the complex or entity screens a little bit later on. Remember, in one of the earlier lessons, we were looking at the idea of entity being a complex of records inside Sage CRM, which make up what we mean to be a business object. So we'll look at that. We'll look at the idea of table and entity level scripts, and I will be mentioning the status for Sage CRM and detached or delayed table level scripts into the future. I'll be pointing you at an advisory that was released just at the moment in which 2023 R2 was released. We'll discuss the objects that are available to us. We will consider the way in which we can grab values coming in from the interface. There'll be a little bit of a discussion between the idea of the values and form values collections. Strictly speaking, they are methods, but they behave in much the same way as a collection. We'll look at the availability of contextual information and consider behavior associated with rollback as well. So it's a lot to cover in the 60 minutes that we've got. But let's have a look at these validation scripts. If we remember, we looked at validation just in passing when we started to talk about the different types of rules. Now, this is a screenshot of the case entry screen. You can see here that I've started to define a new case. Now, in this particular case, I'm only using a create script. So a create scripts can have, and every field in a screen can have different scripts associated with these different moments: the create script, the on-change script, and the validate script. You saw that there was a message being displayed as I was starting to create a record. Well, that's associated with the display of the field onto the screen, the inclusion. That's where we were looking at the idea of create scripts. Now, if you remember, I explained that these scripts are fired when the screen is requested from the browser, as each of the field definitions that make up the screen are pulled up from the metadata. This triggers the fields to fire they're create scripts. And that means the create scripts are executed on the web server within the CRM application. So they're server-side scripts, but they're in the context only of that rather atomic nature of the individual field as it's assembled into the screen. That has implications if you remember back on the scope of reference and the scope of effect that we can have. Now, create scripts, and you can see here one of the uses of the create scripts to be able to change a field into a type of display. Showing here on the transform this in so that a picture can be included in a person's screen. Create scripts are mainly used to change the properties of fields and to change the HTML delivered into the screen, as I pointed out just now. So create scripts can read the context of the information that is in each screen, but one of the limitations of the create scripts is that they can't interrupt the commit process. For this, we need to start to think about what's going on in the browser, start to think about the nature of the resubmission of data into the system. But in our last lesson, we looked at the things that actually took place within the browser, and the most interesting thing when we're in a browser is that we can change anything that we like about the structures inside the browser. We can determine which mode the screen is in, whether it's in edit mode, whether it's in view mode, and individual fields that have an on change moment. We can take advantage of the fact that our fields in our metadata definitions can have scripts associated with them that that will fire when they detect the value in the field has been altered. The classic sort of use of that, as I showed you, the typical work that it does is to act as a way of correcting data that is being entered into the screen. So here I've typed in Costello in capitals, and it's being automatically corrected to the correct case. Now, all this is within the browser. At some point, we need to save that and get it into the database. And so it's at the moment we submit the HTTP request to store that, we post the information to the database. It's at the commit time when each field within the screen can have then a validation rule check. And this validation rule check can check the quality of the data to make sure that the data does not break any business rules. So validate rules are the ones that can block the insertion of data into the database. You know, it's really this behavior that is the focus of what we're going to be doing now. So as I've talked through all of those different types of rules, all the different types of script locations, the create, the on change, the validate, we can see that they are performing in different ways. The very first one, the create script that I put up, was simply displaying a message onto the screen. The second one did a little bit. It changed the data, it corrected the data, it didn't display a message. So you can see the combination of rules don't have to be informative to the user, they can do things automatically. But what they didn't do, either of those, was block the actions. So we're going to be exploring now restrictive rules within validation, and in a little bit we'll look onto the idea of automated change across a wide area of the system, which is through manipulation. So we've got these 4 types of rules: restrictive, corrective, and manipulative. And the restrictive and corrective rules can also be informative, telling the user what's happening. If we go on to our covering of all the different scripts, we understand each of those rules are largely characterized by a specific type of behavior. But interestingly, you can start to restrict user behavior outside of a validation rule. So we actually discussed how you can hide buttons using a create script. You can hide buttons using client-side behavior. We're also going to see how you can use validate rules for more than simply saying no to a user. We'll see that we can use it for other effects as well, guiding as much as anything. But what we've seen is that there are limitations to each scripting environment. And this is because we have to consider each script has a scope of reference and a scope of effect. The scope of reference is concerned with the objects available to the script, the access to the system that it has and to the database. And then you've also got the questions about the environment. What are the variables that are just within the context of the browser and the server? And the scope of effect is concerned on the action that the script can perform. All of this is different depending on what you're doing. Now, the primary purpose of a validation rule is to enforce the integrity of the system. Here you happen to see that I'm looking at a case summary screen, and if I start to change the screen, we need to see that there are rules that have to be followed. Now, when we were discussing right at the beginning of the course, we looked at the idea that there are lots of different types of business rules, which can be simply implicit in the nature of the data type that Sage CRM allows us to define. So a lot of the referential integrity inside Sage CRM is maintained not through any scripting that we do, but by the nature of the fields that we have to force a particular lookup from one table to another, and that ensures that widows and orphans can be eliminated from the system. We don't have those breakages of referential integrity. And we can also see that we can restrict fields by drop-down lists, and we can also make sure that fields are mandatory, that have to be completed by ensuring that they are marked as required fields within the field definitions. But as we come to working with a validation rule, we can actually reference any of the information that is being submitted to the server. So we consider two fields on the screen. Now, as we look on these, neither of these fields have been defined as mandatory, but if I put a value into the SLA field and then attempt to save, what we see is that there is a validation error. There is a moment that the system blocks the commitment of the data to the database. If I attempt to save here an SLA, a case with an SLA, but no SLA severity defined. So there's been a blocking on that. Now, this is all defined within the definition of the case screen. In this case, it is the case detail box, and we can see that there is a rule, and this happens to be a default rule within Sage CRM, which gives us a very useful teaching example that we can look at. We can understand that it's using well, let's expand this a little bit further. So if we have a look at this source code that I pulled out from this, we can see that our behavior is using something called values. This values method, it's a system method within the scope of the validation rules and server-side script to be able to read the value of a field in the screen. So immediately, validation rules are very different from create scripts, because create scripts don't have any sense of any other field, except they can look into the database and into the general context. But here, values allows us to see what has been submitted by not only this field, but another field. So immediately we have got a interfield and intra-record check about what's going on. So I can read not only the case service level agreement ID, but also the service level severity field as well. Both are being able to be examined. And just to remind you that the double ampersand symbol is used within the if condition to mean that both conditions must be true in order for this to be allowed. Now let's have a look at what we can start to see in our scope of reference. Now that variable valid, if I look back here where we saw valid equals false, is a flag field. It's used to indicate that something, well, has gone wrong. In this case of the validation rules, it would potentially allow us to trigger a message as well within the error string. We've seen that variable before, but it is just one of the server-side variables that we met when we looked at the create scripts. So like create scripts, validate scripts are executed on the server, and we have access to all of these fairly standard CRM objects that we can use. And there you'll find those all documented within the object reference within the developer guide. You might see them as the ASP reference, but they are in fact the COM reference. Now there are different variants of how these objects are used in different places within CRM. So there'll be a slightly different expression of the COM API, whether you're using it internally or using it externally. So the internal COM APIs that use this would be the create script, the validate script, what we'll see in a moment within the table level and the entry level script. And there's yet another family of script with other classes that is used solely with the component manager. Because they're all taking place server side, they have then a different usage. And for example, the valid and the error string are not used on the client side scripting, and they're not used in the ASP instance of the code. If we continue to look at this, we understand that when valid is set to be false within a validate script, the database commit is interrupted. When a valid is set to false within the create script, it only will allow a message to be displayed. So validate rules interrupt the commit process. Now, that rule on its own starts to give a sense that we aren't just checking the information in an individual field, but we can check the contents of fields in other information that is submitted. By extension, you could think that a validation rule is an ideal point in which you can check that the start date of something has to be before the end date of something. And I think that there are some examples of that within the campaign entities, if you want to have a look inside CRM for those. But we can get interested here now in complex cross-entity rules. This is where we want to be able to look between not only our record, but other records, either within the system or within the screen as they are being submitted together. And here you actually happen to see that I'm in a marketing screen. And in this case, this is something that I have written. I've written a rule on this, and the rule has this particular case has been triggered because I've broken the campaign budget. Now, I've tried to define a budget in an individual way. The effect of this is going to be checking all the other waves that already exist within that campaign to see if the waves now go over the allowed campaign total. So this is all about budget control. That script might look immediately a little bit complex, but it isn't actually, but it is demonstrating the scope of reference that we can use. If we read through this, and server-side script, by the way, inside Sage CRM does need to continue largely to use the older style JScript conventions of var rather than things like the let or inst. So we're looking at here at just the plain var definitions because of the scripting engine that we're using. But we can start to see in here where we've got the budget being ascertained, being pulled in, var values, wave budget. We're using the idea of context that we looked at back in the create script lesson, going crm.getContext campaigns, and we're identifying which campaign we're working with, and we're also getting hold of using a trick here of not just getting hold of the campaign ID, we can get hold of any field from that parental record. So if we've got a record in the context, and I'll be reminding you about context, you can use a get context call to get any of that parental records information. Essentially what this statement does is it does a select star from that table or that view. And if it does a select star from that table, it does it once, and any further get context calls are cached and it doesn't do an additional database fetch. So it's got that get context, and here we're then looking at the finding of a record. And this is where we need to step beyond the context call and look at other records that match our parental campaign, or in this case, the parental campaign. So we're looking at all the waves belonging to the campaign. We're then setting the initial counts values for total waves budget and the broke budget by amount value, and I'm running through there and doing a simple while loop, working out and totaling up the total waves budget, or getting that, and then also getting the waves entered and doing the calculation. So not a terribly complex one, but if you've not met those methods before, then it's worth looking at the examples to see how you perform fetches of information. Now, this did rely on this idea of context, and context is used within validation scripts in exactly the same way as we see them being used in create scripts. That means, as we see our script, the context information of this campaign is used to allow us to retrieve all of the other records within the waves that belong to the campaign. Knowing the initial context allows us to go and open up and get any data within the database. And of course, straight away, we're not just looking at a single record. We are looking at cross-table and cross-record calculations here, allowing us to work out what's going on. Now, the complexity, therefore, is not in the rule itself, but rather the way in which some rules could then start to interact with others. Now, this is a rule that we looked at when we were dealing with the create scripts. We looked at the simple rule that says the user is just about to do something that they should be blocked about if they continue to do it. So this is where we've got a create script which is warning somebody they're starting to create a case, and this company doesn't have a service level agreement. What that looks like as a create script is a message onto the screen. So this is an example of a rule that is informative to the user, But remember, create scripts don't block. If we wanted to block this behavior, we would have to define it as a validation rule. So it would only fire, or it would fire as the data is submitted to the database. So create scripts, warn and inform, validate scripts, block the bad data from the system. What that looks like is that you can very often end up defining for yourself different expressions of the rules. But interestingly, we can also have not only create scripts working alongside validation rules, you can start to match some of the validation rules with equivalent behavior on the client side. This is so that we have very much a design philosophy of belt and braces. If you're not an English speaker, you might not recognize the phrase, but belts on your trousers and braces on your or suspenders, sometimes you might know them as suspenders on your trousers, also keep the trousers up. Belt and braces means that you're using both mechanisms to protect exposure or inappropriate data events. And we can you can define a rule either as a validation rule or as an on-change rule, and the effect is that you're experiencing two levels of defense there. One, correcting data, and then making sure that nobody sneaks in and tries to do it behind the scenes. We'll expand on that a little bit later on as we come on to the table level scripts, because there are ways in which we can do a further check at the level of the table so that we force a correction of the data as it comes into the system using a table level script. Now, one of the jokes about validation rules is that they shouldn't just be about saying no. This is a conversation that I would have with my children, and saying that as a father, my job is not just to say no to things, it is sometimes to say yes to things, or to do other jobs. But validate rules have a main purpose, that is to protect the integrity of the database by blocking submission of data that breaks business rule, but they can be used for other purposes. And one such purpose is actually to introduce mandatory behavior in a search screen. One of the problems that you can run into is a very slow search environment created by people doing fetches of data where they haven't filtered the data. So you're immediately sending a give me to the database without any sense of restricting what you're trying to look at. And what you can do is you can add in a validation rule to insist that fields in search screens are populated. Now, this is because, and this is valuable because although you might make a certain field a required field within the field definitions of a screen, actually fields in search screens ignore the required rule that is set up at the field level security point. So because you're not actually entering data into the system, so reasonably it ignores it. But because we can define the rule within the screen, we can now insist that a particular field is completed. And that's as simple as checking to see whether there is a value contained in the particular field. And if there isn't, well, put an error up, force an error, valid equals false, and then put an error string up to see that. So there you go. In this particular case, we're looking for the company name within inside the company search screen. Very, very simple. Or you can get more complex with validation rules. Now, this is a validation of a rule that can detect when a field is changed. This is where you can insert a rule into a screen which isn't ever going to say valid equals false and force an error. It will just look to see whether data was changed and then write an audit into a log. And so that is some of the ways in which we can use validation rules. Have a look inside the system. Go and look into the screens and see where you can pull up examples of default validation rules inside Sage CRM. It's an interesting thing where they're used. They vary in complexity. They're well worth an explore inside the screens. Now, I think that's probably enough about validation rules, because I want to look now in the last half of the session on table and entity level scripts. Table and entity level scripts are defined under the customization options for a particular table, company, person, etc. And there are different types of available script. The types that I'm going to teach about are table level and entity level with rollback. There is in fact a fourth type, which is called a detached or a delayed table level script, but these are going to be deprecated in Sage CRM 2024 R1, and these lessons are going to be for a while, so as they are going to be finally removed in 2024 R2, I'm not proposing to talk about those. The advisory that you see here talk about how you can use an alternative method using escalation rules to achieve the same result. We will be looking at escalation rules in a subsequent lesson. So let's explain the different types of scripts that I am going to talk about. So table and entity level scripts use the idea of event functions, and they are analogous to database triggers. And event functions, we use event functions already because we've used an on change, and that's a browser field event function. These happen to be custom event functions within our own system, and you can see, or probably it's just off the screen there, it is a table level script. It is a very simple update event function. What I've done in here is to simply recognize when an update is occurring. Now you'll notice that there are inside a table level script 4 event functions: insert record, post insert record, update record, and delete record. You must make sure that any record that you define, anything that you have got, contains that those definitions. So you must make sure that you have got insert, post insert, update record, and delete record in any of the scripts that you start to write. But by default, you will see that they are created automatically for you. But don't go deleting one just because you're not defining it. It has to exist in the table level script that you're dealing with. These scripts, and if we look onto their usage, if I change the data in the main company screen, that little script will fire. And so here it will say a company update event has been triggered. Now it's called a table level script because it's looking at the interaction between the submission of the data and the commit into the database. And you've got the moments of insert, and then immediately after the insert, and then the update, and the update, and then the information that we've got in the delete. Table level scripts are independent, therefore, of the screen. They work in custom screens as well, so they're not dependent on the interface. And we can see this if I change a custom screen right at the beginning of the training. I created this simple demo screen, and if I change the data and save, it fires in here. So the script is saved and the table level script is triggered, displaying the message. Now, this is the same rule executed wherever the change takes place. And that could equally have been a SOAP-based web service call or an API call using the API call using the .NET or the classic ASP pages. So these script interactions for the table and entity level scripts are taking place after the moment of the validate, which is associated with the screens, as the data is being committed into the system. Insert, post-insert, update, and delete. Now, our definition, if I change the table level script to an entity level script, we'll start to see that the behavior is very different. We'll see in this case that the script is triggered on the company summary screen, but it's not triggered in the custom screen. So it is tied to the system action that is being used here. We'll be looking at system actions as we go through our customization, still into the programming of this, but I did touch on system actions when we created our custom screens in the first place, because we looked at the idea that this is a system action called runBlock that is calling this particular custom screen. But our screen is not like the system screen. That system screen is the company summary system action that has, there are a number of different system action codes associated with it, but they all point to this block of behavior called the company summary. And the company summary then is one of the entity level script firing points. And they're used in a very, very tightly defined way. So they're used in the context of, and this is entity level scripts. It's used when a new company or a new individual is being defined. It's used in the context of when we're editing something or deleting something in the context of the company summary or the person summary. And in fact, really, entity level scripts are only focused on these three broad business objects: the company, the person, and the phone and email combination. And it is only available on the defined function, as you can see here. Address is also included in this, but very often you're entering this in the combination of the person and the company. If we look to see this, the differences are that table level scripts work on all tables, even custom tables. Entity level scripts only work on those core contact tables, and then you're working with different main events. So a post insert record is what is used for a table level script. It would be the insert record for an entity level script, and so on. So you've got both able to do the update record. Now, one of the big differences between a entity level script and a table level script is if you are working with something as complex as a company screen, you could make rollbacks. If somebody is trying to enter a non-existence address into a company, you can check for that and roll back and say, you can't enter this into the system. If you're trying to, if you've got some inbuilt behavior that does a company house lookup, and wherever you are, I know that, say, Ireland and the UK have this registration of all companies. If you've got a company number, you can do an immediate lookup on company's house to see the status of that company, to see whether it's still trading and what its registered address is. And if that's not the correct address in company's house, you can say, hold on, we can't allow this information to be entered. Let's have a look at the idea of rollback in action on a fairly straightforward example. We can use entity level script with rollback, and this allows us to stop, a rollback allows us to stop the action happening. So this is the equivalent of the validation rules. Now, we have to think about how we're coming to enter the data and updating it. But if I think here of the company entry screen, this is complex, and this is where we've gone past the deduplication screen. We're now on the full company entry screen, and you can see that we're not just in the business of entering a company record, we're in the business of entering a person, address, and set of phone number fields. How do we make sure that the data is not going to be incorrect? Now, where we used validation before, when we used the validation rules before, we were using the values collection to look at all of the data being submitted in that screen. But not all of the data is in the company box long, or the person box long, or the address box long screens, which are used in here. These are the block definitions within Sage CRM. So what we can use in addition to the values collection is the form values collection. So these methods, I keep calling them collections, pseudo collections methods, they allow us to read the inbound data in subtly different ways. So the values collection allows the data within the fields associated with an individual block or screen that is being used to build the edit screen for the current record. So that, if you were writing your code and you wanted to use and access any of the fields within the company box long screen, and you were writing the rule associated with one of those fields, then you can use the values method or collection. The form values collection allows you to access the data from within the whole of the HTML form that is being submitted. And this means that in a screen like the new company screen, when you're actually inserting data to several tables, company, person, address, phone, whatever, then you can access any of that submitted data. So in an insert event function for a company entity level script, we can access all of the address information. We can go and say, form values, open brackets, address, postcode, to get hold of the postcode if we wanted to. This is a very big advantage for us, and if you want to explore this further and how you can start to add in validation using entity level scripts and with rollback, then the blogs are where you need to go. If you have a look at validating phone numbers and emails, there's an old article in there, but it's a good article. It should still be correct in terms of allowing you to validate behavior of email and phone numbers into the system according to the rules that you want to have in place. So what are the main uses of table level scripts? Now, in themselves, we see validation rules can interrupt the commit process. We've seen that entity level scripts can interrupt the commit process and entity levels, and that's the entity level scripts with rollback. So those are the two mechanisms that you would be using for the prevention of bad data getting into the system through the use of restriction. Rules can be corrective in nature and they can be manipulative in nature as well. Corrective is where we are updating data within a single record or a single field, and manipulation is when we are wanting to be able to make a change across the entire system. And table level scripts, although they cannot interrupt the commit of a record, nevertheless are probably the most useful type of script to be able to effect a cascade of changes inside a system. This is the manipulation of data. Imagine a customer has a requirement when a company was reassigned to a different account manager. All the opportunities that belong to that company were still, well, you'd want them reassigned automatically, reassigned to the new company manager. If you're looking and wondering about the display of the screen, I've added in here some of the stylistic changes in one of the components that we assembled for the demonstration of behavior. This is through client-side control of grids. With our behavior, though, we can update the change. And this is a table level script put into the company. So it's an update record event function. Remember, it would have to sit with the three other scripts event functions. So here you can see we're using values to be able to get hold of the submitted value from that screen. And we know we're in the context of the company, so it's assuming the company is being the main context. So values from that main screen, and we're able to then, with that context, get hold of the opportunities associated with that context, and we are able to then look to update all of those. Probably the chief line is this idea of crm.getContext info is being compared with the values of the comp primary user ID. So that's the test that tells, is the data in the database and that I originally loaded into the screen, is it different from the value that is being submitted now? And so that allows you to test whether something has changed. So as something has changed, you can do all of the other behavior. And in this context of what I'm doing is changing the user. We will have examples of manipulation behavior in the blogs within the system, so do have a look at that. Now, I had shown you in the on-change example and the client-side behavior how we can introduce behavior that makes sure that data matches our expectations. In the case of that, it was the check case, making sure that as names were entered into the systems, they were correctly initial capitalized. Now, occasionally we need to be able to correct data that has been submitted to bring it into tolerance like that. Now, an example of this may be where someone has chosen a customer credit limit that's too high, and we need to change this to a maximum allowed value based on the customer's current outstanding orders. So that's an example of where we want to be able to look at the existing orders and say, well, actually, anything that you enter has to be moderated by the existing credit they've got. So the table level scripts allow us, because of this is the scope of reference, it allows us to look at any of the existing data in the system and implement the business rules that we need. Now, the key thing that enables to bring data within tolerance is a strange bit of behavior of the value method in the context of table level scripts, and that is that the values, the field grabbed inside the values method is addressable. So we can start to use this to change or override the inbound values to what we need them to be. It's a very sneaky thing to do. Again, there are examples of this on the community. If you go and have a look at the roundup for table level scripts, you'll see that there are lots of examples there. Now, another example might be where we need to ensure that when a company is reassigned from one user in a team to another user in another team, that the opportunities also move to the correct new team. Now, the opportunity should be assigned to the team to which the new user belongs. So if you reassign it, move their team as well. So we need to get around the problem of users reassigning opportunities against incorrect teams, but correct users. This isn't that difficult then. The trick here is spotting when the assigned user changes. And then, so we are using again the idea of this get context info method, returning the originally assigned user and the values collection containing the inbound user data. When they're different, we know that the record has been reassigned. Okay. Now, I talked through the different event functions earlier on. And you will have noticed that there are two insert event functions available to you, seemingly within table level scripts. You've got the insert record and the post insert record. This is, well, if we look at the insert record first of all, the insert record fires as the record is created, but before the database inserted. Therefore, any unique identifier for the record is going to be unknown. You don't know what has been inserted yet. The post-insert record does have access to the record's newly created record. So there are a couple of variables that suddenly become useful to us. When we are creating a new record, one of the things that we can't do in a insert is a get context, because the record is new and is not in context at that moment. And neither can you use a values collection, because the thing about, if you remember back, is that we deal with identity columns, and the identity columns for newly created records won't have been passed into the system. So you can't use the values collection or the form values collection. There has to be another way of getting information within the moment of the post insert. And this is where we can start to see what that is in the post insert to obtain the newly created record ID. So we can use a where clause to be able to get hold of the information. So post insert, find record company where clause. So we can see what has just been inserted within the where clause and then return that up into the browser. These are the different places that we can use each of these objects. Now, I haven't said anything about the current user in the context of what we've been doing so far within the table level scripts and the validate scripts, but just like The create script can use current user, so can the validate rules and table level scripts. So you can see the current user object is available everywhere. Interestingly, it's available client side, so it's available to the on-change scripts as well. But the valid and error string, these diagnostic tools, very often, as I've used them for the informative behavior that they provide, and as well as the triggering of the blocking behavior for entity level scripts with rollback and within the behavior in validate rules. So valid and error string are available server side. Values and form values are available again server side. And they are very useful with coming into their own really in the context of the entity level scripts, or where you want to get a field that isn't in the block but you know is in the form. And then the where clause is the last thing that you can play with, and that is very useful within the context of the table and entity level scripts, or entity level scripts really, as we've done the post insert, table level scripts as we've done the post insert. That brings us just to the end of this session. So we've now looked at all of the screen-based behavior. So we've looked at the create scripts, the on-change scripts, the validate scripts, and we've taken these validate scripts and we've compared them with the behavior of the table and entity level scripts. So we're going to be moving on from this now, starting to look at workflow next week. And I hope then this has been a useful session. So let's see if anyone has got any questions. Thank you very much, everyone, for coming along. I look forward to seeing you at the next session. Thank you so much. See you then. Bye-bye.